All right, so right now we're going to get started on our next advanced lecture in our series of kind of bonus topics today. And this lecture specifically will be about Web3. And just to kind of get a sense at like where the room is, how many people have heard of this concept before? Okay, so not too many. So don't worry. The goal of this lecture will essentially be to give a very high level overview of kind of what this word means and some of the underlying technology behind it. And I encourage everyone to like ask questions if anything's confusing. This is meant to, be really useful just for you to give you a high level overview of what all these things mean. So if we kind of get derailed, don't worry. I'd rather, answer any questions that come up and have everyone understanding everything. So to just kind of give a roadmap of what we're going to be discussing today. Is it frozen? Or
it's like very cut off.
All right. So what we're going to be talking about today, again, is like this topic of Web3. And to kind of build up to that idea, we're going to be talking about a few topics that kind of gave rise to this concept in the first place, starting with decentralization. We'll then move into kind of how this leads towards the idea of blockchains, and finally talk about some topics that you may have heard about in the news recently, including things like NFTs. So let's get started by talking about decentralization. Yeah, go for it.
2022 called, they want that slide deck back.
Thank you. I actually just made these this week, so these are from 2024.
Okay.
But let's just continue, I guess. So yeah, let's get started with decentralization and Bitcoin. And to kind of motivate why we care about this in the first place, let's consider an app that we're all probably familiar with. And this is Venmo. So this is an application that allows users to send money to other users via their service. So kind of to get an understanding of how this will work, let's say Alice wants to send $5 to Bob. What she'll do is she'll go to Venmo and say, hey, I want to send $5 to Bob. Venmo will acknowledge this and adjust each user's balance accordingly, decreasing Alice's balance by 5 and increasing Bob's balance by 5. And then finally notifying Bob that Alice has sent him $5. In this scenario, this is great. Alice and Bob are happy because they're able to use this service to easily transact money between each other. However, we can imagine a slightly different scenario where instead Venmo is kind of sus. And this can be due to a variety of reasons. For example, maybe instead of using a trusted service like Venmo, this is like a third friend. So you have to, you're not sure how trustworthy this friend is, or maybe it's some random website you found online. So again, you're not really sure whether or not this service is reliable. Again, let's consider the case where Alice is sending $5 to Bob. And let's say this sus Venmo correctly decreases Bob's balance by 5. However, what would happen if after decreasing Alice's balance, this sus Venmo doesn't actually increase Bob's balance? In this case, Bob will be sad because he hasn't actually received the money that he should have received from this Venmo. A similar scenario could occur where this sus Venmo could lie and say, tell Bob that he's received $5, but in their actual database, only increment his balance by 4. And eventually when he goes to spend this money, he'll find out that this sus Venmo has lied to him and he won't be able to spend that complete $5. A third scenario could just be simply that this shady Venmo character doesn't allow Alice to even begin this transaction in the first place. So essentially denying service to Alice entirely. In this case, Alice would be sad because she's no longer able to use this service. So all of these scenarios kind of point to one idea, which is that putting one person in charge, and this is what we call centralization, can be bad, especially when the person in charge isn't a trustworthy party, as in the examples we just saw. So this kind of leads to the idea of decentralization, which is a scenario in which no single person is in charge, and anyone can kind of join the system and play a part of it. It's worth noting here that many of these so-called decentralized systems you may have heard of are not actually decentralized because it's very difficult to achieve this in practice. However, we'll kind of see one system that does a pretty good job at this. And to kind of see how this will work, what we're going to do is build up an analogy to like some sort of public bulletin board. And the way this will work is every user will have their own copy of all of the data in the system. That way that like if one person is trying to change things, they won't be able to affect everyone else in the system. As I mentioned before, like trying to actually achieve a decentralized system can come with a lot of problems, and we'll kind of walk through what those problems may be in a bit. But just to kind of see how this will work at a high level, as we mentioned before, we can draw an analogy to a public bulletin board. And let's say this public bulletin board will list the balances of all of the participants in our party. Going back to like our example we saw before, let's say Alice wanted to send $5 to Bob. What she could do is she could post on this public bulletin board a message confirming that she, in fact, does want to send $5 to Bob. Importantly, what will be included with this message is a cryptographic signature from her, which allows everyone to verify that this message was truly sent by her and couldn't have been forged by anyone else. Similarly, if Bob wanted to send some money, he could do the same thing by posting a message to this public bulletin board and signing with a cryptographic signature, confirming that he indeed is acknowledging that this message is valid. So this is all great. At this state, anyone would be able to look at this public bulletin board and kind of compute the balances everyone should have. So they can look at this and say, Alice has minus $5, so 45 in total. And Bob has, for example, like minus 5 as well. And Carl would have $10. Does everyone kind of see how like this would allow monetary transaction to occur in the same way that we saw before? Okay, sweet. So I'm getting some head nods. As always, like if you have any questions, just feel free to interrupt me at any time. So this is all great, but this leads towards a problem. Specifically, it's actually possible for Alice to game this scheme and double spend. And the reason for this is because we said it's a public bulletin board, which means that everyone will have their own copy of the data. So this kind of leads to the question of like, what would happen if the copies of the data that people have are different? And to kind of see how this would work, let's imagine the same scenario looking at before again, where we have some like Alice, Bob, and Carl, and they're all trying to transact money between each other. Bob would have some copy of this bulletin board on his local computer that would look like this, and Carl would have the same thing. And now let's say Alice was trying to be sneaky. And what she will do is she will send, or I guess just to confirm what we're seeing here, like this top part is all Bob can see because this is what's on his computer. And let's say Alice is trying to be sneaky here. And what she wants to do is she's going to send $5 to Bob. And again, with this cryptographic signature, Bob will look at this and be like, okay, I see that Alice is sending me $50. And let's say that Alice used this to pay for like some physical goods. However, since Alice is trying to be sneaky, she doesn't actually send this update to Carl. So what Carl sees is still a blank bulletin board where she has access to $50. Now what she can do is she can actually do the same thing to Carl. She'll send Carl a message saying that Alice, send $50 to Carl. And Carl will think that she's like actually sending him $50. And so, for example, maybe Carl will give her like apples in exchange for this. However, if we like look at what like the entire state, we'll see that this has actually allowed Alice to spend those $50 she had twice. She spent them once by kind of sending Bob a message telling him that she's sending him money. And she spent it a second time by sending this message to Carl, kind of telling him that she has sent him $50. And I'll pause here because this is like a pretty important example and like demonstrating why these types of systems are difficult to achieve. Does it make sense like why this scheme allowed Alice to spend the $50 she has twice? So again, just once again, like what happens is Alice has started with these $50 and she has sent a message only to Bob saying that she's sending him $50. Carl doesn't see that message. So Carl still thinks Alice has those $50. And she sends a message to Carl saying that she's giving Carl $50. So at the end of the day, both Bob and Carl are tricked to believing that Alice is sending them $50, even though she only has $50 in total to give. So the reason this is like even arising in the first place is because the participants in the system are not agreeing on the complete state. So what we need is a way to achieve consensus, which is essentially meaning like everyone that's belonging to the system is agreeing that the state is exactly the same. It's like actually very difficult to achieve these in distributed systems in general. And if you'll take like some more advanced classes in your time here at MIT, for example, 6584 or the old number is 842, you'll learn that like even non-blockchain based consensus protocols are very difficult. And to kind of just like compress a whole semester into a few slides, I'll give some intuition of why this may be. So let's say that we had this idea of electing a leader to hold the true state for any given like public bulletin board. And that leader will be the one to like manage the entire state for everyone so that there's no conflicts. And let's say that we're going to choose the majority based off of whoever receives the majority of votes. Well, one problem is that some users could actually vote twice. And if this happens, like it's possible for multiple users in the system to think they got the majority of votes. So for example, in this three-party system, the majority will be 2. So whoever gets 2 votes will think they're the leader. And in this scenario, both Alice and Bob will think that they're the leader because they've received 2 out of the 3 votes. And this will cause problems because now again, once we have 2 different leaders who are both supposed to be like holding the ground state of our entire system, the ground states will be able to diverge because we have 2 different leaders that can make different decisions. Does everyone kind of see like why this would be an issue? Okay, cool. And the thing is like, even if we could solve this issue of like preventing participants from voting twice, there's still another issue, which is that anyone's allowed to vote. Like we don't want to be denying service to any party or any individual. And what this kind of opens up is the idea of like this Sybil attack. And to kind of demonstrate what this would be, ideally everyone in the system would be like voting honestly and only voting once from one account. But because anyone's allowed to vote, one user could pretend to be an honest participant, but in reality make an extreme number of accounts and flood the voting system to effectively like skew the vote in any way that participant desired. So kind of the moral of these stories is that like this voting process is very difficult. And even if we could solve it perfectly, like any malicious users, so anyone who's like breaking the rules and not acting in everyone's best interest, will be able to break the system. So a lot of people were thinking of this problem, like how we could resolve them. And this is kind of what led to the idea of Bitcoin. So the idea behind Bitcoin is essentially that computational power is very expensive. And we can kind of utilize this idea and say, we're going to make it necessary for anyone that wants to change the system. We're going to make it necessary for them to have lots of computing power. And essentially like this public bulletin board we've been talking about is the blockchain in this Bitcoin system. And this concept of needing lots of computing power to make updates to this public bulletin board or to the blockchain is called proof of work. And what this relies on is the assumption that the majority of people in the system are good. So like to see how this would work, like let's say one person wanted to make updates just themselves. It wouldn't be possible for them to amass enough computing power as just an individual to make updates that would benefit themselves. And we'll kind of walk through that same double spending example and see how this system would prevent that double spending example from occurring. Just to kind of like dive a little bit deeper into how this Bitcoin would work so that we can walk through our example. The way Bitcoin is set up is that all transactions occur in these things called blocks, and users would agree on which blocks are valid. So essentially, which transactions are valid on this blockchain. And the key question is like, who can propose a new block as the next block, and thus like the next transactions? And the answer is someone who can solve like a very difficult puzzle. So these puzzles are what requires lots of computational power to solve. And again, the idea is that a single malicious attacker would not have enough computational power to solve this puzzle and propose like a malicious block. In the ideal scenario, only large groups of good acting users would be able to solve these puzzles by working together. And finally, a crucial insight of the system is like, there's no reason for any of these users to waste their computational power solving these puzzles unless there's particular incentives for them. So the way that Bitcoin solves this is that they'll actually pay the people to solve these puzzles by paying them Bitcoin. And this is what's known as Bitcoin mining. So if you've ever heard of this term, essentially what this means is people that are doing Bitcoin mining are running lots of computers to solve these puzzles. And anytime they solve these puzzles, they're getting paid in Bitcoin. Specifically, what these miners will do is they will take pending transactions and they'll place them into blocks. And whenever they solve a puzzle, they'll be able to add that block as the next block of valid transactions. So does that kind of like at a high level make sense to everyone? Okay, cool. And again, like the TLDR is the transactions will be placed in these things called blocks, and only people who can solve a difficult puzzle will be able to add new blocks and thus add new transactions to the blockchain. Let's go back to our double spending example and see how this Bitcoin system could actually prevent it. As I mentioned before, there'll be like some pending transactions that miners will be looking at and adding to blocks. So let's say that there's one pending transaction of $50 from Alice to Bob. What will happen is miners will take that pending transaction and put it into a new block on the blockchain, thus confirming that it's valid. Later, like Bob may spend that $50, and again, like a miner would put that into a block and make that a valid transaction. However, now let's say that Alice was trying to be sneaky again and wants to try to double spend that $50 she had and send it to Bob. The way that like this would be prevented is the miners would see this and be like, yo, you can't do that because we see that you've already like spent those $50 by sending them to Bob. And like if Alice wanted to like override the miners and try to make this a valid transaction herself, she would have to solve that very difficult puzzle entirely on her own to make it count as a valid block, which would be effectively impossible given like how much computational power is required to solve these puzzles. And like even if by like some random chance she was able to mine like this particular block by solving a very difficult puzzle, it still wouldn't be considered as valid because whenever there's like a branch in the history of like the transaction history, only the longest chain will be accepted. And this is generally the one where like the majority of miners, which we presume to be good, are working on. So typically only that one majority chain will be considered valid. So this is like essentially the crux of like the Bitcoin system and how it prevents double spending. So I'd also like to pause here and just like have everyone kind of look at it and kind of convince yourself that this makes sense. So again, what would happen if Alice wanted to try to double spend this money is that she would need to solve a very difficult puzzle herself, which is effectively impossible. And even if she was able to, it wouldn't be counted as valid because there would be an existing longer chain of transactions that would take precedence. Cool. So this is essentially what I was saying, like, because only the longest chain is accepted, it's effectively impossible for someone to double spend themselves unless they like have the majority of computing power, which again is like not physically possible. So with that, we've kind of successfully built up our decentralized monetary system. This Bitcoin monetary system, which kind of runs on this underlying blockchain, with a system of blocks that contain transactions. But one thing that's cool is like once we have this system, if you notice, we can actually like do more than just money with this. For example, instead of like sending money to other people, we could send something like an NFT. And we'll kind of get into what this is in a bit. But essentially, like the high level idea here is that we don't only need to use the system for money. In fact, we can post like other types of messages on this public bulletin board or this blockchain. For example, we could say like, oh, Alice like will pay 2 Bitcoin for this NFT. And we could like codify these arbitrary messages in some type of coding language and put them to the blockchain as well. So a lot of people were thinking about like this idea and how we could use these blockchain systems for more than money. And in particular, this guy called Vitalik Buterin and some other people developed this system called Ethereum, which is essentially a way that we can combine this Bitcoin blockchain protocol with arbitrary code. So just to kind of give like a description of what this is, at a high level, you can think of Ethereum as exactly the same thing as Bitcoin, but with code. The key feature is this potential to create smart contracts, which will hold code and data. And in the end of the, like at the end of the day, they'll act almost like an API endpoint that can be called by different types of clients. And these smart contracts will be how clients will be able to interact with the blockchain on any websites that you may build. These smart contracts are able to do things like computations, make transactions, and more. And similar to Bitcoin, there will be these miners that will execute smart contract code and kind of put up the results in these blocks. And as we'll see in the next few slides, like the idea is that many of these computers or many of these miners will make up something called the Ethereum virtual machine. And we'll see kind of how that interfaces with our web applications in a bit. One side note is that the Ethereum system no longer actually has miners. There's a different type of system that prevents like malicious users from doing whatever they want. It's called proof of stake. If you're interested in that, we can like talk about that later. But I guess just to show like exactly how this Ethereum system will interact with web pages, we'll kind of move on. So as I mentioned, like a bunch of these minor like actors in the Ethereum system will make up something called the Ethereum virtual machine. And you can kind of think of this as like a distributed backend server. So if you remember in our traditional client server model, we'd have like many clients talking to one server. This is exactly the same thing, except for instead of one server, we'll have many servers that are also talking to each other. And again, these will be like the things that are holding that public bulletin board that kind of represent our blockchain. Each of these computers will, as I mentioned, hold that public bulletin board, the blockchain, as well as a bunch of smart contract code, which, as we mentioned, are kind of like the API endpoints that let clients interact with this blockchain. And to kind of just like get a better idea of what one of these smart contracts may look like, we can see they actually just look like very normal code. There'll be like a name for like the entire class. In this case, this is like a bank smart contract. And there'll be some functions here. You'll see deposit and withdrawal, which behave exactly the same way as like an API endpoint. So once this contract is on the blockchain, any clients will be able to access these functions, and specifically here, either deposit money or withdraw money from this smart contract on the Ethereum blockchain. Here's like another example from a project that I worked on a few years ago. It's not super important to know the details here, but essentially you can see like on the left-hand side, there's some smart contract which would be deployed to the Ethereum blockchain. You'll see there's a few functions here like give prize. And in our node server code, we can see here that we're actually calling this function here to give a prize to one of the participants of our website. So I think I'll actually skip this for now, but at a high level, like one more nuance with the Ethereum system is that any user that wants to make transactions or computations on the Ethereum blockchain will need to pay for that. And that's a concept known as Ethereum gas, which is like pretty interesting, but I don't really have time to go over in detail. If you're interested, feel free to come find me after and I'd be happy to talk more about this. Okay, so we've been talking a lot about like decentralization, Bitcoin and Ethereum, but like how does this all relate to our original topic, which was like Web3. So like, what is this Web3 thing? And a disclaimer is that like it's a bit of an overloaded term, so it can mean many different things to many different people. But the things that this like it all shares in common is that it's this vision of a future where many websites are built with this distributed blockchain backend rather than a traditional single server. And the reason people are excited about this is because it achieves a few things like decentralization, trustlessness, and transparency. And to see how like the Ethereum system would fulfill all of these purposes, we'll go through these one by one. So first of all, any application built on the Ethereum blockchain will be decentralized because the backend, that distributed Ethereum virtual machine we were describing, is distributed across many different users. So that means one malicious user wouldn't be able to kind of interfere with the way that the server is behaving. The next is trustlessness. Due to the way that the Ethereum blockchain functions, users don't have to trust that there aren't other malicious users in the system. And again, this is because of that miner protocol where like any miners will not allow invalid transactions to occur. Finally, any application built on the Ethereum blockchain will be transparent. And what I mean by this is that like any smart contract code that's published ever is public and can be verified by users. So like users don't have to trust that whoever wrote the code is like doing something right or like not being sneaky anyway, because they can just go ahead and read that code themselves and verify that it's doing exactly what they want it to do. Okay, cool. So at the end, I just wanted to like leave you with some vocab that you may hear due to like the increasing popularity of both like cryptocurrencies and blockchains in general in both like popular media as well as in technical settings. So the first is the idea of a token. And in the Ethereum blockchain, this is essentially just like some type of data. And many people create their own tokens on the Ethereum blockchain. Essentially, all you need to do this is to keep track of everyone's balances and kind of have a way for them to exchange these tokens for other types of things. And here's like an example of smart contract of something that would implement a token. So you can see there's functions that we'd expect from any type of monetary currency, like transfer, transfer from, and mint. And one nuance of like Ethereum tokens in particular is that they have this approve function, which essentially allows like one user to spend tokens on behalf of another. There are like a few reasons why you'd make a token. The first one is something called a stablecoin, which is essentially a coin that's meant to track some real world asset. So these are things like USDC, which tracks like the US dollar and things like that. Increasingly, there's been some movement to also create tokens to represent other types of financial assets. So these could be things like stocks, bonds, or even partial ownerships of loans. And we'll go into like how this can kind of change the economic ecosystem if these things actually become popular in a bit. But yeah, just like, again, like the stablecoin is a token that's meant to track some real world asset. Typically, these are like USD. So USDC, USDT, and DAI are all examples of tokens that are meant to track the dollar one-to-one. Finally, there's this idea of fungibility. And to kind of get a better understanding of what this means, there's like two types of assets in the financial world. One of them is called fungible, which means that it's interchangeable with other types. So for example, a dollar bill would be fungible because if you exchange a dollar bill with someone else, it represents the exact same thing. You still are in the same exact state you were as before. However, there's also assets that are non-fungible. And these would be things like artwork, cars, and stuff like that, where like, if I exchanged one non-fungible thing for another one, I wouldn't be left with the same thing at the end of the day. And when this is a token, this becomes something called a non-fungible token, often abbreviated as an NFT. And these things shown here are these things called Bored Apes, which were like a very popular like NFT craze, like a few years back. So you may recognize some of these images. And with that, like all of the major buzzwords, I think, that are popular in the news have been covered. So if you'll like ever, tune into like some sort of financial news or anything like that, maybe you'll hear some of these terms and have a better understanding of what these actually mean. Now, finally, I just wanted to leave off with some comments about what you would do if you actually wanted to make a Web3 application. So back in the day, like what you would do is you would learn Solidity and you would maybe learn some cryptography. However, I've updated these slides to like include maybe because I think the technology these days is a lot better. And I think anyone could get started on building a Web3 application, even if they don't have a super good like foundation in cryptography or other specialized languages. I'm not super familiar or up to date with what the newest technologies are, but I'd definitely be happy to like talk about people if this is something they're interested in. And here I've shown like some logos of popular websites that are built on the blockchain backend. Just to go into like what some of these are, Axie Infinity is like a very popular Web3 game where you can kind of like obtain these characters, which are represented by NFTs, and kind of have them battle or trade with each other. So almost like a Webkins, but with NFTs. There's this thing called Decentraland, which is essentially aiming to build a metaverse-like platform, almost like Roblox you can think of, with a blockchain backend, again, interfacing with things like cryptocurrencies and NFTs. There's OpenSea, which is a very popular NFT marketplace. So this would allow people to exchange NFTs for different types of cryptocurrencies, etc. Uniswap's also a very popular website. Here you can trade different types of cryptocurrency tokens with each other. And finally, there's this website called Fortuna that actually was built in WebLab a few years back, where you can kind of like do online gambling to win these tokens that are specialized to the website and then trade them for specific NFT prizes in some marketplace. And I'd highly encourage people to check out this website on the WebLab website if you are interested. So I just like to end with some closing comments. I guess like I do want to make it clear that I'm not like super pro blockchain. I do think there's like definitely lots of advantages that can come with like moving towards a more distributed blockchain. But of course, there's always like disadvantages as well. And especially right now, like the cryptocurrency ecosystem is pretty filled with scams. So I'd definitely be careful about anything you hear about in the space. But just to kind of like discuss some potential possibilities for the future if this technology does become widely accepted, there's like possibilities for things like housing deeds and mortgages to be stored in the blockchain as NFTs, the possibility to get rid of physical signatures with better cryptographic signatures, and also things like improving peer-to-peer lending processes without the need for like intermediaries like lawyers or banks. And the reason for this is because like all of these things can be codified exactly in code and then put into the Ethereum blockchain, which means that it becomes the ground truth forever and no one can kind of tamper with them. And there's not any like disputes about like, oh, who owns the housing deed, like who owes who. All these things are like set in stone in the blockchain. And just to end up with like some food for thoughts, like I guess especially in the US, we like this idea of democracy. So it begs the question of like, why don't we also want to democratize our monetary system, kind of removing the need for intermediaries like banks and kind of gaining control over our monetary system ourselves. And it's interesting to think about like how that could influence the economic ecosystem in the future if someday banks are gone and all replaced by, you know, like digital banks on the cryptocurrency ecosystem. So that's all I have prepared for today. I guess I'd like to see if anyone has any questions on any of these topics. Okay, great. Well, thanks for listening. And again, as always, like if there's any questions, feel free to come by after lecture, post on Piazza, or if you're thinking of building like a Web3 application yourself, I'd be happy to help you in office hours.